Hello and welcome to Mathematical Universe. So in this universe, we're looking at logarithmic and exponential equation. I will be solving question 1, this logarithmic and exponential equation. So we're having 16 raised to the power of log x minus 2 base 4 plus 10 log x plus 1 minus 4 log 5 base 4. So we have to find x. That's the objective. The objective is to find this x in this place. So we have to first suppose we have 7 from the law. I just want to assume a number. So let's assume we have 7 maybe 7 log 9, or 7 to the power of log 9 base 7 equals to 9. That is, we are certain that this expression is going to equal 9. Then let's call this equation 1. So from there we can deduce, let me write my suppose first. So we can deduce that I can derive equation 2 from this. What do I mean? I want to make the power equate something. That is, this log 9 base 7 should equate something. I want to use this to be able to solve that expression there, so you can see a pattern there. So let this equals x. So as this equals x, let's call it equation 2. Now we can substitute the value of equation 2 in equation 1. But before we do that, recall from logarithm law that 7 to the power of x will definitely equals 9. If you recall from your major logarithmic law. So this we call it equation 3. Now I have equation 1, 2, and 3. Now I'm not going to say, I'm going to substitute the value of equation 2 in equation 1. I want to put equation 2 in equation 1. So substitute equation 2 in equation 1. Now we already have equation 1 to be 7 to the power of log 9 base 7. However, instead of putting log 9 base 7, so I'm just going to write 7 to the power of x, because I already made it equal x in equation 2, right? So it means 7 to the power of x is equal to 9. Let's call this equation 4 if you want to, but that's not the objective here. So let's substitute equation 3 now. We substitute equation 3 in equation, we have to just write it there. So let's call it equation 4. So substitute equation 3 in equation 4. Then we have that, 7 raised to power x is 9, so it means 9 equals 9. But if you do not understand from this concept, let us use another example to show that that expression is true. Let's get another example. So suppose we have that same question. We have 7 to the power of log 9 base 7, and it's going to be equal to 9. How can this expression equal 9? So let's see. We take the log of both sides. That's the second approach. We take the log of both sides, or you can say take the ln of both sides. Then we take the log of both sides. It's going to be log 7 raised to power, I didn't create space, log 9 base 7. Let's close the brackets. Then equals to log 9, because we are taking log of both sides. Then from logarithmic law, if I have a power, that is logarithmic law of power, if I have log m raised to power y, this is the same as saying y log m, because the power moves to the left hand side, then multiply by the function. So same thing is going to happen to that. So log is moving behind, so I'm using my red pen to write that instead. So the power comes down, then multiply by log 7, equals to log 9. Then what will happen is, looking at this expression here, we can write it as saying that is using the change of base. All what I'm doing here, I'm using the logarithmic log. So let's use change of base. So I want to change that base. It's going to give me log 9 over log 7. As simple as that. Then multiply by log 7 equals to log 9. Now you see log 7 can nullify log 7, so we are left with log 9 equals log 9. So it means that expression is true. So when I have an expression like maybe a general expression, a to the power of log, let's say x base b, then definitely this is going to give us x. It's going to equate that function as long as I have a and log to the power of that expression. So I'm supposed to write a and that is the power and the base when they are equal. So the power becomes the actual function we are looking for. So this one equals 5. That's what it means, because we have 4 log 5 base 4. So it's going to give us 5. Now let's look at it now. Let's look at the question once again. So that expression is going to equal 5, and we have negative there before, so that's why we have negative 5. Now what about the let me write this properly. What about the equal 0? Now what about the middle expression? So this one is like saying log base 10, because there is no base there, so obviously it's a natural log. So and this one also will be left with x plus 1, because we're having 10 carrying the base over there. So this is going to remain x plus 1. Yeah. So then this one, to simplify this, you can write it as 4 square. 16 is same as 4 square, then log of x minus 2 base 4, because 16 and that base does not match, so that's why I had to convert it to 4 square. Now let's move on. So from here we can say that 4 raised to power 2 times 3 is also same as 4 raised to power 6, right? I just want to recall something. And this also you can write it as 4 raised to power 3 times 2. So all these statements are true. So I want to interchange, because I want to interchange that first term there. That's why I'm doing this. So take notes. Now it means I can interchange this as 4 to the power of log x minus 2 base of 4, then all into, that is all into 2. It's still the same thing, just like you're saying 2 multiplied by that power plus your x plus 1 minus minus 5 equal 0. So what should be the next step? Now, judging from what I just did here, it means same issue that happened now, 4 and 4, the power and the base. So definitely we'll be left with x minus 2 raised to power 2, x minus 2 raised to power 2, then plus x plus 1 minus 5 equal 0. Then we can open that expression. We know square means x minus 2 and x minus 2 in 2 places. So we can multiply using the algebraic expression. X times x, then x times minus 2 will give us x squared, then minus 2x. Then we can do for the second term there, 2 times x, then minus 2 times 2 as well, to give us minus 2x. Then minus times minus is plus, then 2 times 2 is 4. Now when you express it further, it gives us x squared minus 2 give us minus 4x plus 4. Then recall the ones we left behind before. The remaining term, we can bring it down. That's the 1 at the top, bring it down. Sorry about that. Then the 0 as well, bring it down. So now we can have x squared minus 4x plus 4 plus x plus 1 minus 5 equal 0. I'm not putting it into parentheses again. Let's just solve it that way. Now let's look for the like terms. So I will indicate it with different color. We have the constants 4, 1, and 5. They are constants here. So plus 4 plus 1 will give us 5, and 5 minus 5 will give us 0. So it means those constants are gone. Then let's use green to indicate the other one. We have minus 4x and we have plus x. So it's just like minus 4 plus 1 to give us minus 3. So it means for the green like term, for the red right term, like term, it will give us 0. For the green like terms, we'll have minus 3x. So we'll just input it into the expression as x squared minus 3x equal 0. Then what's the next step? We notice x is common, right? So bring out x, then we have x minus 3 equal 0. Then what should we do next? By quadratic, this is x equals 0 or x minus 3 equal 0. So this x minus 3, we can write it as x equals to positive 3. When 3 moves to the other side, give us positive 3. So it means our solution is x equal 3 or x equals 0. But we are going to choose x equals 3 and nullify x equals 0. Why? Let's go back up. Look at the question. If we put 0 for x there, we'll be left with minus 2, and we can't have negative logarithm. It's not possible. So it will render the equation invalid. So 3 will be the best to use. So if you plug in the value for 3, you'll get that expression to equal 0. Le fini. Thank you very much.